Foundations of Business Analysis students, and welcome to this Excel tutorial on the Bivariate Chi Square test. We use the Bivariate Chi Square test when we are comparing two categorical variables. What the Bivariate Chi Square test enables us to do is to determine whether or not those two variables are independent of each other. That is, whether or not the frequency of observations within the categories of one variable affect the frequency of observations within the categories across the second variable. So let's jump into Excel and have a look at how this test is performed. So what I've got open in front of me here is my real case study data file. The first step in order to perform a chi-square test is to create a cross tabulation where you compare the two variables. The way we do that in Excel is by inserting a pivot table. So I go Insert and Pivot Table, and I've created that on a new tab. In this particular case, what I'm going to do is I'm going to determine whether or not the fireplace variable is independent from the energy variable. That is, does what value that the house has for a fireplace, i.e. whether or not the house has a fireplace, affect the type of energy used within the house. So I drag my variables, my fireplace variable, I drag down as my row label, my energy variable as my column label, and I'm going to take my fireplace variable and again put it down here in the sum of variables field. The key thing there being, be careful about the default. For me it's defaulted to doing a sum, so I change my value field settings to a count. In front of me now is the cross tabulation table. This is measuring the observed frequencies for each of the 1,200 houses in the sample. That is, the cell that I've got highlighted here, there are 293 houses that do not have a fireplace, the fireplace value is 0, and use gas energy, the energy value is 1. So forth for each of the other cells here. Now to perform a chi-square test, what we do is we compare the observed frequencies that I've got in front of me with the expected frequencies. And the expected frequencies are the frequencies we would expect to see if the two variables were independent of each other. So to calculate expected frequencies, the first thing I'll do is I'm going to highlight this table. I'm going to copy by pressing Ctrl-C. Then I'm going to right-click below, click Paste Special, and then Values. The reason for doing that is just for providing a table in the same format. Now I'm going to use this table. I'm actually going to delete the observations because I'm going to recalculate those 6 observations as expected values using a very simple formula. The expected value in every cell is the row total for that observation multiplied by the column total for that observation divided by the total number of observations. So here I can say that if the two variables were independent, I expected to have 355 houses that don't have a fireplace and use gas energy. I can do the same now for my second variable, or my second observation here. And what I'll do is I'll populate the entire table using that same principle where for every time I'm going to say the expected frequencies is the row total multiplied by the column total divided by the total number of observations. So I go through and I'll complete that for the 6 different categories. Okay, so here I've got my completed expected probabilities or expected frequencies table. Now, I can quickly jump to the chi-square test in that, as we learned previously, we can calculate the p-value for our chi-square test using the chi-test formula. So as we can see in this cell here, H3, I've got equals and I type chi-test. My actual range are going to be the 6 cells that have my observed frequencies, comma, my expected range are my expected frequencies. Close my brackets and you can see I get a p-value that's effectively 0, which means I reject the null hypothesis. Now the null hypothesis here is that there is no difference or that there is no association between the fireplace and the type of energy used. The fact I reject that null hypothesis tells me that there is some degree of association between those two variables. Now last of all, if I want to actually create or calculate the test statistic, the chi-squared test statistic, which is actually the first step in the process that we can use to identify our p-value. The formula for calculating the chi-squared test statistic is that for each cell, I look at the difference between the observed and the expected frequencies. I square that difference and I divide it by the expected frequency. I then sum that together for each of the 6 observations. So in this case here, I could say that my chi-square test statistic is observed minus expected for the first category, squared, divided by expected, plus, for the second option, observed minus expected, squared, divided by expected, plus, observed minus expected, squared, divided by expected, plus, I do this all the way through for the 6 options. And you can follow me here. I'm just adding those values together each time. And I come up with my F statistic, or my chi-square statistic, and that's the test statistic that was used to calculate that p-value. But what we've just demonstrated there is how to perform a chi-square test in Excel. Very important test for us to use when we're comparing two categorical variables. Thank you for listening to this video presentation.